The lunar eclipse of January 2019 was based on our experience with lunar eclipses in 2015 and the lunar eclipse in 2018, both of which we filmed through Overcast. This time we were determined to find clear skies. In the week leading up to the eclipse, there was one storm after another in California. We watched the cloud cover forecast for the western states. 3 days before the eclipse, it appeared that eastern New Mexico had the clearest forecast and the darkest skies. So we decided to drive to Rodeo, New Mexico to film the eclipse. The morning of the eclipse, the forecast changed to partly cloudy skies. The evening of the eclipse, the moon rose into overcast skies. The only partially visible star was Sirius. Nevertheless, the moon was visible through the overcast, and we began to shoot one picture every 6 seconds. We used an Ioptron 90mm refractor telescope and a Canon 80D camera. Our initial shutter speed was 1/250th of a second at ISO 200. At this point, the shadow of the Earth begins to be seen on the bottom of the moon. Our strategy was to slowly change our shutter and ISO speeds as the eclipse proceeded. For this video, 4 minutes of real time is 1 second of time-lapse time, and we wish to avoid a sudden change in the appearance of the moon. With a slow enough shutter speed, the blood moon begins to become visible. Watching the moon, we saw the sky filled with stars as the moon became dark. The blood moon was spectacular. It was shot at a shutter speed of 2 seconds, ISO 1600. Once again, the detail of the moon's surface is visible in the pictures. In the time-lapse, the brighter side of the moon moves from the top of the moon to the bottom of the moon. The moon begins to emerge from the Earth's shadow, and the process to shorten the shutter speed begins. It seems that the moon moved from the eclipsed state to the partially eclipsed state much more quickly. Once again, it can be seen that the overcast is beginning to reassert itself. During the partial eclipse, we were quickening the shutter speed twice as fast as we had slowed it earlier. At this point, detail on the moon's surface once again begins to appear. The moon appears to pulse as the shutter speed is increased perhaps each second of elapsed time. The moon has emerged from the Earth's shadow and the final penumbral phase begins. In the final penumbral stage, it is overcast that affects the moon's brightness. The camera details remained unchanged.